Hi, welcome to another video, vMotion. In this video, we will examine what are the prerequisites for vMotion, how the vMotion process works. vMotion is a zero downtime live migration of workloads from one server to another. There are two kinds of vMotion, host vMotion and storage vMotion. In host vMotion, we migrate the virtual machine from one physical host to another one without changing the storage. But in storage vMotion, we migrate the VMware files from one data store to another without changing the physical host. Advantages of vMotion. vMotion helps to move the VM during maintenance. In case of any maintenance task on the underlying physical host, we can migrate the VM to other available hosts in the cluster. Second one is balance workloads. In case of high CPU or memory usage on the physical host, we can move the VM from that host and balance the workloads across the cluster. vMotion prerequisites. These are the two main prerequisites for vMotion. The participating host must be licensed for vMotion, and second one is the host must meet the networking requirements for vMotion. Means we should configure each host in the cluster with at least one network interface for vMotion traffic. There are other flavors of vMotion like vMotion without shared storage, cross vCenter vMotion, and long distance vMotion. All these demands different requirements. When a virtual machine migration is started, the vCenter execute a migration task that involves the following steps. First one is a compatibility check. So vCenter checks whether it is possible to run the virtual machine on the destination host. Second one is a migration specification is created. So vCenter creates a migration specification that involves the following information. So it includes the information about the virtual machine that is being live migrated. What is the configuration? Like virtual hardware, VM options, source and destination ESXi host details, and vMotion network details. This migration specification is shared with both source and destination ESXi host. So then the vCenter server communication happens with the ESXi host as given below. The VPXT agent, which is present on the vCenter server, communicates with the VPX agent on the ESXi host, which in turn transfer the information host T, and host A communicates with the VMX. So there is a bidirectional communication between the VMX and VMM agent in the ESXi host. So here is the vMotion process before the actual memory transfer begins. So the migration is initiated, then vCenter server starts a compatibility check, then a migration specification is created. So this information is shared with both the source and destination ESXi host. And as we discussed earlier, the communication from vCenter to host ESXi host happens like this. So the VPXT communicates with VPXi with host T shares information with VMX, and there is a bidirectional communication between the VMX and VMM, and this in turn communicates with the VM kernel migration module. And VM kernel migration module is responsible for ensuring that the sockets are opened for the vMotion traffic to begin between the source and destination ESXi host. Okay, now the VM kernel migration module has opened all the ports for the vMotion process to start. Now all the processes and communication paths are ready for the live migration to begin. Now the first phase in vMotion is prepare phase. So in this stage, the destination ESXi host pre-allocates the compute resources for the to be migrated virtual machine, and also a virtual machine will be created on the destination ESXi host. In the second phase, the pre-copy phase, this is the phase where the memory is transferred from the source to the destination ESXi host. The VMM agent is responsible for tracing the memory pages. So page tracing is a continuous cycle. Memory copying is an iterative process. For example, if we are transferring 16 GB memory from source to destination, in the first phase, the 16 GB virtual machine memory will be copied. During this phase, its date is the 4 GB. Then in the next phase, this 4 GB memory will be copied. So during this phase, suppose that if another memory 2 GB is dated, so in the next phase, it will copy the next 2 GB. During this transfer, if 1 GB memory is dirtied, in the next phase, this 1 GB memory will be copied. So if the last memory copy page can complete, the last one can complete within a window of less than 500 milliseconds, memory copy will be terminated. So we have copied all the memory from source to destination. Now it is switchover phase. So the VMM terminates the pre-copy migration. Then now all the memory pages resides on the ESXi host. Now VMX will enter a checkpoint phase. So it will suspend the source virtual machine and will send the checkpoint data to the destination host. Checkpoint data is the information that the destination ESXi host needs to boot the VM. So the ESXi masked ESXi destination VM will resume, pointing to the checkpoint data supplied by the source ESXi host, and the VM continues exactly the same as it was in the source state. So here is the vMotion process summary. So first a compatibility check is done by the vCenter server. Then vCenter creates a migration specification and is shared with both source and destination ESXi host. VM kernel migration modules ensure that all the processes and ports are open for the vMotion process to begin between the source and destination. Then it enters the prepare phase, where the destination host pre-allocates the compute resource and creates a virtual machine. Then it is pre-copy phase, where the actual memory is transferred from source to destination. Once the pre-copy is terminated, switchover phase happens. In the switchover phase, the source virtual machine will be suspended and it will boot the VM on the destination ESXi host with the checkpoint data supplied. Thanks for watching this video.